Welcome everybody. I'm Klaus Ibsen to this Camel microservice talk. So yes, I was here 7 years ago in 2011. Back then it was 100 people in one room and one talk at a time. I'm really pleased to see how the community and the conference has been going strong since, so congratulations to that. Thank you. So I am a software engineer from Red Hat. I've been working on Camel for 10 years, 9.5 as a full-time developer. I wrote 2 books on Camel. Camel in Action second edition was just published 3 months ago, and it's a little big book. So Camel is easy, just read the book. And I'm from Denmark. So what is Camel and what do you use it for? That's a very good question. So Camel is used for system integration or integration. So Camel is that little piece that sits between systems and glue them together. Now, from a developer point of view, Camel is categorized as an integration framework or integration toolkit. Here are the 5 highlights of Camel. So you go about using Camel to build integration where you use enterprise best practice. And those are known as enterprise integration patterns, which I'm going to talk about in a moment. Now, Camel comes with more than 200 components out of the box. And you use these components to connect to many different systems. It can be anything from mainframes to legacy systems to more traditional enterprise systems, Oracle database, IBM WebSphere, messaging systems using DMS, AMQP, RabbitMQ. It can also be streaming-based like Kafka, and also traditional SOAP web service, RESTful service, and of course also file-based, FTP and secure file copies. There's also for social media with Facebook, LinkedIn, and Twitter, and so on. And all the way to more modern settings with clouds. So you can use Camel with Amazon Web Service, Google and Microsoft Azure. And there are also cloud service you can access like Salesforce and SAP and ServiceNow and a whole host of other components. So more than 200, and it keeps growing. Now, the third thing is that Camel comes with support for data mapping and transformation out of the box. That allows you to transform your data between different structures. So you can transform from Java to XML and vice versa to JSON, YAML, and also more traditional with flat files and comma-separated files and so on. And there's also support for a number of industry standards in healthcare and finance. Now, in Camel, you define how systems are integrated using routes, Camel routes. And as a developer, you develop these routes in either Java code or XML. And finally, Camel has support for REST and APIs. So what is enterprise integration patterns? That's in fact a book with that same title. That book is the equal size of this one. So about 13 years ago, Gregor Hobby and Bobby Wolf, who are the authors of that book, were a consultant that went from client to client and helped with integration problems. And they saw the same problems over and over again. So what they did was to write down using notes about these problems and how to solve them. And after a time, they got so many notes that they thought, maybe we could turn that into a book. And surely we should be blessed for that. This is the Enterprise Integration Patterns book. It's a highly recommended book. And you may say it's the integration Bible. In this book, we have recipes or solutions for common integration problems. Here are on the slide some of them. There's one called content-based router, which is a very famous pattern. So it's more like a Java if-else thing. You can also filter messages. You can route messages in a dynamic way. You can send a message to a number of recipients. You can split messages. You can aggregate, and so on and so on. The book has 65 patterns. Camel implements those patterns and some additional patterns, which we're going to see later in this talk. So what about Camel routes? So here is a very basic example of Camel. We want to integrate 2 systems, a file system with a messaging system using JMS. And it's very, very basic. It's just say from file to JMS. And in XML, it's similar way how to define that. Now let's use a little more advanced example. This is, in fact, still quite often used today. So you need to pick up a file and split that file line by line. And each line you need to do some sort of message transformation, and that information you need to send to another system, maybe a message queue. And in this example, we are using Apache ActiveMQ, which is a message broker. So you can use 4 patterns from that book. And here's how you can implement that in Camel using Java, for example. So you just say from file, and then the directory name. Then you want to split, and then you tell Camel how to split. You want to split the message body using a tokenizer that is using a new line character, so it will be split on line by line. Then you want to transform that data to XML in this example. But this example is picking up files that has some sort of custom in-house format. It's not a standard format, so you need to implement how to transform that, and you provide that to Camel. And then the result of that transformation is sent to a message broker with just 1 line of code. So in essence, we have 4 patterns that maps to 4 lines of Java code that its Camel can run. That is very beautiful. Now, what is the high-level architecture of Camel? Well, this is it, 1 picture. So in the center, you have Camel context. So what is Camel context? Well, that is Camel. That is the runtime Camel. So the idea is that you have this Camel context, then you can add Camel routes to it. And in these Camel routes, you can use these enterprise patterns where you can do messaging, routing, transformation, validation, enrichment, call your own business logic, and so on and so on. And on the bottom, you have Camel components, which you use to connect to all the different systems, to kind of like to speak to the other systems. That is the Camel architecture. Now, where can you run Camel? Well, I say Camel, you can run Camel anywhere. Well, Camel is based on Java, so everywhere you can run Java, you can run Camel. Now, because Camel has been around for 10 years, then it supports both the older way and the more modern way. Probably the other way around, it's flipped for you guys. So in the beginning, where we are building more traditional applications that runs on application servers, then Camel works beautifully there. But now, today, when we are moving towards a more microservice and container-based solutions, then you can also run Camel in that environment. And this will be the focus of this talk. Now, Camel also connects to everything, or a lot of things. I said that Camel comes with 200 components out of the box. And on this slide, I tried to categorize those into 4 different categorizations: the traditional enterprise systems, the public cloud, and the SaaS. But pay attention, down in the corner, I have IoT. So Camel also worked with the IoT world with small embedded devices. Hey, you may say, do Camel really run on these small embedded devices like a beacon or something like that, or maybe on this smartwatch? No, it does not, because as I said, Camel is a Java technology, so it requires to run on Java, and Java itself is a bit heavy, right? The footprint of Java is too much. But where it makes sense to use Camel in IoT world is in gateways. So all these small embedded devices connect to some sort of gateway that is a lightweight computing node that may run Java, and you can have Camel inside. And then, these beacons and whatnot, they can connect to that gateway using lightweight protocols like COPE and MQTT, which has support for that out of the box in Camel. And that gateway can then route that message or data to a backend system where you can further process that data. So that is also a very common approach of using Camel. So you can see it spans the entire way of integration today. Now, I would like to summarize what Camel is using pictures. So Camel is this integration toolbox, which allows developers to use these tools to build integrations. And you as a developer, you can build integration solution using best practice. Those are the enterprise integration patterns. Then you can define Camel routes, how to integrate the systems where you can use these patterns and your custom business logic and whatnot. And then you have all these camel components you use to connect to different systems. And all that together is Camel. Okay? So what about running Camel in the cloud or in the containers? So this is where it gets a bit more interesting. Let me just take a sip of water. Sorry for the pause. So when we start to move from a more traditional way of where we have been building more monolithic application to a more microservice way, then we start to split up our bigger application into smaller pieces, and those are known as microservices. And then gradually over time, as we split up, the original monolithic application fades away, and these microservices become more and more independent. And they also become networked and distributed. So now we have a different situation with distributed computing. And that is actually quite harder than what we used to have before. So before, with the monolithic application, it was easier, arguably easier to manage, monitor, and troubleshoot it, because if something goes wrong, well, we can check the status of the monolithic application, is it up or down? Now, when we have many different microservices that run in a distributed computing fashion, they are distributed, they run on different nodes, they are communicating remotely over the network, and so on. Now, in this situation on the slide, we have just three services, A, B, and C. So if A calls B and B calls C and something goes wrong, where is that error? How do you troubleshoot that, and how do you figure that out? That is where it gets more complicated. So what we need is a set of extra features or capabilities to support running microservices in this new world of containers. And here on the slide, we have those. It's a shape of 10, and the Greek word for 10 is deca. So this is a decagon. So we can build microservice that has APIs. And you can have multiple microservices and you want to integrate your microservice. So microservices should be able to discover each other and those APIs and invoke those APIs. And you also want a cluster that can scale up and scale down your microservice, so it should be elastic, and so on, and so on. But where do we get these capabilities from? Well, we get them from Kubernetes. So Kubernetes is this container platform or container orchestration engine that gives us some capabilities like Kubernetes makes it easy to discover other service, it makes it easier to invoke existing service in the cluster, and Kubernetes certainly makes it easier and manage scaling up and down service. What about additional features? So you can run what is called a platform as a service on top of Kubernetes. One of those is Red Hat OpenShift, but there are others in the market. What they typically provide is solutions around common needs, around continuous integration, continuous delivery, for example, around pipelines. So we can have like Jenkins pipelines and whatnot. But you also need a centralized logging and monitoring solution for the cluster. And in recent time, a new concept has emerged and become more popular. It's called Service Mesh. And one of the products inside the Service Mesh ecosystem is called Istio. And it kind of stands out. So Istio tries to be a solution to manage your service and connect your service in a more secure and reliable way. So we get some resilience from Istio, something around security and tracing and so on. And the final piece is about API management. So when you start to have many APIs in your clusters, then hundreds and thousands, how do you manage and govern those? It can be rather complicated. So what you want to do is to be able to sort of have an API catalog, so to speak, so developers can browse the catalog and find your APIs. They may have a one-stop page where they can read information about the APIs, how to access the APIs, and what are the contract of that API. It could be a JSON, Swagger documentation, etc. Also, when you have many APIs, and you may want to have sort of like a solution for user management. So they can self-sign up for accessing APIs. They can hand out tokens, API tokens, to access the APIs, and maybe you need a way of revoking API tokens that has become invalid, or security issues, and so on. So the host new of problems that an API management solution can help to solve. But where is Camel? He sits there, but where is he on that slide? Well, Camel is embedded inside your microservice. That's where you find Camel. So here we have different microservices using different technologies, and I have said before that Camel is Java-based, so Camel can only run inside the Java-based microservice. So on the slide, it will be Spring Boot, Vertex, Wildfire Swarm, etc. You cannot use Camel with Go or Node and other things like that. Okay. So when you start to have microservices that are using doing integration with Camel, then it's distributed integration. And so here on the slide we have 3 services, A, B, and C, and we are only using Camel where it makes sense, where we need integration capabilities. And where could that make sense? For example, it could make sense to use Camel on the edges. For example, in Service C, we need to integrate with some external system that runs outside the cluster. And maybe that system is an Oracle database, so there's a Camel component for connecting to a database, JDBC, etc. But it may also just be an old school FTP server, right? So there's a Camel component for that, and so on and so on. There are 200 and so Camel components, so that's where it makes sense. Another point I wanted to make is that now we can take integration where it's needed. So Camel is a lightweight integration toolkit or framework you can embed directly with your microservice and run it directly in that container where you only need it. Now, beforehand, with a more traditional way, we had more like an application server, more like a centralized application server, or maybe even a centralized ESB. That's not longer the case with the container wall, so you can run it where you need it only. Now, companies, when they start to look into microservice architecture style and this movement around DevOps and being more agile and so on, all that is in the integration space, add a coin into a single concept called agile integration. These have 3 key capabilities that you need. One is distributed integration. This is where you find Camel. This is the bread and butter of Camel. This is where you build integration flows. This is where you reuse those enterprise patterns and so on. In the center, you have containers. You want this cloud-native container platform where you can run your microservices and Camel applications in a reliable, robust, scalable, highly available infrastructure. And then you have APIs as well. So distributed integration, containers, and APIs. Now, what about some of the best practice or good practice around running Camel in the cloud or on containers? Well, we want to be small in size. So Camel is very lightweight, around 4 megabytes, the Camel core. Then the intention is that you just piecemeal the Camel components you want together, and then you embed that together with your applications or microservice as this fat jar kind of style. And then you can run those using popular runtimes with Spring Boot, Vertex, Swarm, and Carafe or whatnot, or even just standalone Camel. You don't need that. But being small in size is very important as a practice in the container world. Now, another practice is around being stateless. Favor building microservices that are stateless. They are easy to manage. They're easy to scale up and scale down and so on. But if you need state, then Camel has components with different state solutions. For example, with memory grids, you can have Camel integration with InfiniSpace, Hazelcast, and so on. But also for storage solution with JDBC, SQL components, streaming with Kafka, and so on. And when you run stateful applications on Kubernetes, then Kubernetes also come with a concept for that, which is called a stateful set. Another practice around running microservice in containers is around configuration management. In Kubernetes, there are 2 concepts for that. One is called config map, and the other one is called secret. Now, Spring Boot and Camel has great support for that. So here on the slide, I'm trying to illustrate that. So you can externalize your configuration and provide that as part of the Kubernetes platform. Down in the corner, there is a YAML file that has a single configuration key. There's a key called fallback with a value saying I still got no response. Now, that information can be injected into the runtime container by the Kubernetes using two approaches. One is using environmental variables, and another one is using files. So there will be a file on the container file system with that information. Both of those are, out of the box supported by Spring Boot and Camel. Now, sometimes you want to store more sensitive data, like passwords and certificates and so on, and those are secrets. And those are in fact also possible to be injected on the same approach using either environmental variables or files. But when it's files, it's not stored as a physical file on a disk node anyway. It's sort of like only in the memory, so you can't really, it's more secure in that way. Now, yes, we'll move on. Now, another practice around running Camel or microservice in containers is around fault tolerance. Camel has support for that in two areas. One is called client-side retries, and another one is around circuit breaker. And there's one implementation in Camel for a very popular library called Netflix Hystrix, which we're going to see later on in the demo. Now, when you have distributed integration that calls each other over the network, then things can go wrong. So one thing is that you can we have here on the slide is a hello service, and the client want to call that. Now, if for some reason something goes wrong, then you can instruct the client or Camel to try again, client-side retries. So in Camel, there's something called on exception. So you can say on exception, then the kind of the exception. Here we're just using exception, so it's very generic. Then we tell Camel to try up till 10 times with 1 second delay. And in the second, on the slide, we can see, okay, the first 3 invocations failed. The 4th time it worked. So everything is okay, right? Awesome. Well, not always, because now imagine that you have many microservice or clients that calls a downstream service, and that downstream service is under stress. Here on the slide, that downstream service is called relevance. So all these upstream service call it, and because the relevance service cannot handle that load, it keeps failing. But the client on the other side has been instructed to keep calling you. So, that's not a good situation. And that situation is called a thundering herd problem. Now, a thundering herd is like a big group of cows, angry cows that come running towards you. There's no way really to stop that. You're really fucked if you get that situation. So there are other means in how to build fault tolerance ways, and we're going to see that in a moment. Another great practice you really need on container-based technologies around health checks. It becomes more apparent now because it's more like the container platform itself is leveraging these health checks to know the state of your application, so it really needs to know if your application is ready or healthy and so on. Now, in Kubernetes, there are 2 concepts for that. One is called readiness probe, and the other one is liveness probe. There's a distinction between them, and it's somewhat important to know what it is. Out of the box, Spring Boot comes with great support for health checks, Spring Boot activators, and Camel has an implementation for that, so it comes, if you run Camel with Spring Boot, you get that out of the box. On the screen, you can probably see there's a Camel health check, it says up. So the entire health check is up and for that one, so it's good. Now, when you have, and so why is there 2 different distinctions in the Kubernetes platform? One is called readiness probe, and the other one is liveness. So readiness probes are used to know when your application is ready, up and running, because application may need time to initialize. Especially Java technologies, the Java JVM is a little heavy on the container platform. It needs time to boot up, Spring Boot and Tomcat and so on. Only when they're really boot up and ready, you want to signal to the cluster that you're ready, that you can take traffic. Whereas liveness probe is something that is keep being checked by the platform to know, hey, are you still alive? Are you okay? So that's where it can maybe after it's ready and handling traffic, something can go wrong in your application. So you may say, I'm no longer alive. And then the Kubernetes platform can react to that. The Kubernetes platform is based around this self-healing concept. So it can actually kill containers and whatnot, start them up again, and so on, based on these probes. So one point as well is around these enterprise integration patterns. Is there any, let's say, difference on using them in the cloud on containers? The book was published before we had containers, really, before Docker and Kubernetes. No, there's no. They're just as beautiful on traditional ways, but also on microservices and containers, so there's no difference at all. So you can safely use them on containers. But Camel comes with a number of additional patterns for running microservices in the cloud or containers. I mentioned a bit before about fault tolerance. There was something called a circuit breaker. One implementation of that is Hystrix. It's a very famous one from Netflix. So we're going to see that in the demo. Another cloud pattern that was recently added to Camel is the Saga pattern. I won't go too much in detail about that, but it's more a way of solving the distributed transaction problem with Sagas. Sagas is a way of supporting long-running actions where you can sort of have ways of compensating things. So an example would be sort of like a booking system where you book a flight ticket in a hotel. You can't really use traditional two-phase commits and whatnot, so you can use the Saga pattern to implement that, and then have ways of compensating. For example, if the flight ticket is booked, but there's something wrong with the hotel, then you can make a cancellation for the flight book, and vice versa. One thing you also need around microservices in Camel in the cloud is around distributed tracing. So before we may have this big monolithic application, and you can sort of how do you track a business transaction, so to speak? In the bigger application, it was more easy, but now you have many different microservices. How do you trace that business transaction across many different microservices? And in the open source world, there are different products around that. One is called Zipkin, another one is Open Tracing. And Camel has components that integrate with those. So if you go back to the Decagon slide and see where does Camel provide some capabilities that we can use? Well, we do have, certainly around invocation. To invoke microservice in the cluster or outside the cluster, there are Camel components. Remember, I told you there were more than 200. Also around resilience, even though Istio is coming around, it's still a new product. Camel has client-side retries. It can make sense to use them because it's in Java code. You can implement it directly there and so on. And there's also the circuit breaker from Hystrix, which is a battle test implementation. Okay, so let's move on to see if the Wi-Fi works and the demo works. So I'm gonna do a little basic demo. Sorry, it's about the Hello World example. So we have a simple service. It's a Hello service. It's running using Wildfire Swarm. It doesn't really have to, just Java technology. And there's a client that calls the service continuously. It's running on Spring Boot. So two kind of service. So in the interest of time and so on, of course, I already implemented that. And if I execute and call the service from my web browser, I can see a response here if the Wi-Fi works. It says, when I call the service, I get a response saying Swarm says hello from, and then there's something that is actually the host name of where it's running. And the intention is because we're going to scale up and scale down and so on. So the intention is, of course, you're going to see a different host name as we play, right? Now, I can also call this service from my shell. So I have a little script here called hitme. I'm using Perl, so I can just execute that one, and it calls that one, right? Nothing fancy, right? Now, what is about the client-side application? I have it here. So this is a Camel application I built. There's a single Camel route. It uses a timer. So it's a from timer, period equal 1,000. So that's every second. We're going to call a service, and we want to use a circuit breaker from Hystrix. and the service is calling using HTTP protocol. The service name is called Hello Swarm, and then if something goes wrong, we have our own fallback where we say a fixed response, and then we log that. That's the essence of that one. Okay, so if I go to a shell here, I have in my cluster, I have it here, kube get pods. It's already deployed, decline histories. I can tail the log from that one. Swarm says hello from hello, and it's the same response every time because there's one instance or one pod running with that service. So now, to build fault tolerance applications in the cluster, I'm going to play a bit and we're going to see what happens, right? So if I go to the web console, so I'm actually running Kubernetes using OpenShift. It doesn't really have to be, it's just because I was giving this talk at Red Hat Summit, and at Red Hat we need to use OpenShift. But it does make sense because it has this nice button up here, so it's easy to scale up a service. So if I click here, and it's starting to scale up too, and we should see down here that this guy is going to call the second one. And yeah, now it called, okay, I'm gone. Okay. Okay. Okay, so didn't see anything. So now here we have the client calls the service. There's two instances running. So we have this load balancing thing. You can kind of see there are two running. And can you kind of guess or know which algorithm is being used? Round robin. That's a very good answer, but we'll have to go back 2 years, then it will be correct. Today, it's actually random. So Google found out, but they did some analytics on the clusters and whatnot, and found out, okay, round robin seems like the natural way, right? But they found out there's some sort of predictability in it, so you can sort of give this cascading influence, so it can actually be bad. So random is actually the best one, apparently. But you can choose, and you can also implement your custom if you want. Now, there was this problem in the beginning, I'm not sure you saw it, where it says nobody wants to talk to me. Is there anybody that has any idea why this happened? Because I was actually scaling up an application in a secure way in the cluster. I told Kubernetes, please go from 1 to 2. And why the hell can you not do that in a safe way? You are you're in the right path, so to speak. So yes, you won the book. Just by saying one word, right? He is correct. This is very important. So Java technology is not super fast, and not Spring Boot or Wildfire Swarm, certainly not. Even Camel is fast, but no, just kidding. But it's not super fast. So when we scale it up to 2, Kubernetes spin up a new container, and then it starts this readiness probe. And if the readiness probe just says, yes, I'm ready, it serves traffic. But the Java JVM is booting up. Wildfire Swarm is not really ready. It haven't created the HTTP listener yet. So you get a connection refused, and the client that called it with the historic load balancer, it detects that error and does the fallback. So there is a bug or a problem. Now, this is the Hello Swarm application. So I am a bit lazy. There is a tool called Fabricate Maven plugin that can take a Maven project and build this as a Docker image and the Kubernetes manifest files together, so you can deploy it directly in the cluster. I use that, but there is a bug in an older version of it. So I'm using version 3.3.5. That version has a bug around readiness probes, so it does not include that out of the box. If I upgrade to a newer version, it will include that readiness probe, and it will work. So if I had that readiness probe, I can easily scale up and down my Swarm service in a reliable way. But nevertheless, let's try something else. I just go back to 1 here, and let's see here. Where was it? Up here. I'm going to tail this guy, and down here I can get my pods, and I can, of course, if I delete it, then you'll say, okay, but you're telling Kubernetes to delete a pod, then it knows the service is gone and so on. But what if it crashes? How can we sort of simulate that something is no longer accessed in the cluster without Kubernetes knowing it? So we can go a bit backwards if I can, because it's Docker. I can do a Docker PS, and this is actually a little hard to find on this one, but let me try to see if I can find it. The process for that one, Spring Boot, Hello Swarm. Here it is, and then is, oops. This is probably the right one. Don't do this normally. So I'm trying to kill the process that is running the Hello Swarm. I'm not sure if I got the right one. Oops. Is Docker kill? I killed something. Yes, now it said nobody wants to talk to me. So I actually killed crashed something in the cluster. Kubernetes detected it. It was no longer running. Now it will start up that one. And if we can see it, probably not. I might have, this one hasn't been refreshed. So what you can do as well in the cluster is to get an overview of your circuit breakers. And there's a web console for that called Hystrix. And we should be able to see on the graph if something goes wrong. So what we can do is to simulate that problem again. So I'm just going back here, get pods, and I'm just going to delete it instead this time. Delete Hello Swarm. And now it's deleted. And this guy should start to trigger. So now the circuit breaker is open. It's red. So now you can see it's red, right? It does take a little while to get used to the concept of the circuit breaker, open versus closed. But if you're not colorblind, you can see that red is really bad, and green is good. So now it's back again, but the circuit breaker is closed. Closed is good. It's like closing a bridge or something, then the data can flow. If it opens, then you cannot. So that's Hystrix for you. So let me go back to the slides. We should have a little time for QA as well. So this guy said 8 minutes. So when you get started on building microservice and integration on containers, I come from a traditional Java background. So beforehand, when we were building integration applications and so on for Java EE or whatever, it was heavy Java-based. You know the Java technology, you build a WAR file or something and hand it over to ops guys and they run it on an app server or something like that. And the touch points I had was really around that spec or whatever. All this container thing was not in my face. Now with containers, there's a lot more to learn. And I'm sorry, but this triangle you see here lists some of the concepts. You're not really supposed to read it from the slide. It's more like you can go and download the slides offline and read it from your browser and get sort of like inspiration from some of the concepts you need to learn. We saw a bit about self-healing. We saw that the Kubernetes cluster can do that. But there's also for API, gateways, resilience and service discovery, dashboards and dispute metrics and so on. There's many concepts that you need to master and learn a bit more about when you're developing microservice for the containers. And thank God, there's going to be a number of books which explain that to you. There's a very good book, written by a colleague of mine, Christian Poster, Microservice for Java Developers. It's sort of like a gentle introduction to how it is to build Java microservice. It does not cover Camel, but it does cover how to build Spring Boot applications on containers and so on. It does have like a tutorial way of try this at yourself, so it's a good way of learning it. It's freely downloadable. Now, if you really want to learn the concept of containers, and then there's this great book called Kubernetes in Action. Unfortunately, it's not free. The author, Marco, probably needs some royalties, and the publisher certainly want to have a bit of dollars. But today there is actually a 40% discount code for Java EE folks, so they posted that on Twitter. Unfortunately I forgot to put it in here, but you can also find it on Amazon and whatnot. This is a highly recommended book on Kubernetes. My book, you got it for free, but the other guys, you can order it from Manning, the publisher. There's a discount code called CAMEL39, and it gives 39% of discount. Easy to remember. In the past, they have also had other discount codes for different amounts. There used to be, has been a 50%, Camel 50. Sometimes they forget to revoke them. They are not so IT good, so you can try maybe Camel 99, 98, 97 until you find it. Some of them actually work. So, but Camel 39, this is sort of like it always works, at least to my knowledge. It used to work for the old book and also for the news. I haven't heard about it doesn't work. And just some links. Where is the slides? It's on my GitHub account. Just find me on DAOsCloud, and there's something called Camel Writers in the Cloud, and that's where you can find the stuff. The Camel website is currently ongoing to be more migrated to be a more modern look and feel and documentation. So don't be scared if you go to the Camel website and think it's from 1990 something. Actually, the website looks like it did 10 years ago. Sorry for that, but we are working on that. So after the summer break, there will be a more modern website. The middle link is really about, okay, if you have a colleague that says, what the hell is Camel? You went to this talk, and can you tell me? You can just point into that one, 5 minutes read, get a coffee. It's a great source what Camel is. And that's the time for Q&A, or we can have an early break. Oh, so how does Camel compare to Mule? Camera off, no. So there are like three well-known integration projects in the world today: Apache Camel, Spring Integration, Mule. They've been around for almost the same time. Mule is a traditional ESB platform. It has started that. It's more, it's not like a toolkit. It's more like an app server. Tomcat embedded, and you have your integration way. Recently, they were acquired by Salesforce, so it also have a doubt in the future of that product because Salesforce is not in the integration space. They don't really care about that. It's more about getting your data onto their cloud or together with Salesforce. And Mule can be a component for getting in there. But that's the mind. They don't yet have, Mule does not have the, I'm on record, but still, the true spirit of open source. Apache Camel is from Apache Software Foundation. It's vendor neutral. Red Hat does not have a control over it, nor does other companies. There are multiple companies that have employees that are paid and then work on it. There are contributors from other companies and volunteers and whatnot. It's truly 100% free and open source and have this great license called Apache license. Mule does not. It has their own weird license. So I'd rather compare Camel with Spring Integration, which are more like toolkit to toolkit. And Mule is like a app ESB integration platform kind of thing that just got bought by Salesforce that has a questionable future. Other questions? So, are you? So the question is, what is better in Camel than Spring Integration? So don't take my word for everything because I'm biased against Camel, right? I think both of them are lightweight toolkit. One of the things I said before, Camel has the true open source spirit, neutral, whatnot, and it's a really focus as underpin technology for different companies. Spring Integration is probably one of many Spring products that is not as important to Pivotal than some of the others. But they are both lightweight. Camel has a lot more component. So Spring has only X and Camel has a lot more. But use both if you want. Camel can also run without Spring. For some people that's actually a matter. They are not Spring shop or something. But Camel can run in any kind of environment you like. But give it a go, both of them. But Camel has the new book, even though it's big. So, one last question or? Awesome. I think I will be around here at the conference. You can find me in the hallways or not. You can also reach out to me on Twitter, LinkedIn or email or whatever you want to do. I'm happy to take questions and whatnot. But again, try to get involved in this container world. It's not only Camel that is necessary there, but many technologies are moving toward that world. Is a hard way. There's many new concepts to learn, but it's something that we all must. If we stay away from that, you will be left behind. I'm sorry. Okay.